Hi Eduardo, this is Elisa. I'm going to give this a try and show you what happens once in a while, and I hope it happens this time so I can show you. So what happens is I click on Run Now, and I end up getting, I'm going to move my screen, up in the upper right hand corner I have Safari, and this happens to be my download file. So I'm going to click on the download file, and I'm going to double click on Gravity and Orbits. And sometimes you notice I get the Java message. Previously, I got one that said, "Do you trust this site?" And I said yes. Then I get that little Java. And then what happens is, last time this little box that you see now, "Do you want to run this application?" did not show up. So I'm going to cancel it. I'm going to pretend like it never showed up. And now it's gone. Okay, every time I try to figure this out, it doesn't quite work. It won't stay and do what I'm asking it to do. So anyway, I'm going to click on Run here, and hopefully within a couple seconds, this is going to come up, and you and I together can just sort of take a look at a couple things. Okay, so let's go ahead and go through this rather quickly. We're going to have the Earth orbit the Sun, and I'm going to put its path and a grid there to help us. So the first one is to draw the Earth around the orbit, and you want to label the Earth and the Sun. And what I mentioned in the previous one, the previous YouTube, was that actually it's a little more, the path of the Earth is a little more elliptical than this, but we're just going to draw what we see. So what you want to draw for number one is you want to draw the Earth, the Sun, and the orbit. You can do that on your computer or by hand. We're now going to switch to the Earth and the Moon, and it's going to ask you to draw the motion of the Moon around the Earth and that orbit. So you want to draw the Moon, the orbit, and the Earth, and that's 1B. The next question you can answer based on your observations: what's similar and what's different? D, based on your observations, how would you define the word orbit? I think you can do that one. What holds the Earth in orbit around the Sun and the Moon? Part 2. Explore the simulation to determine what keeps the Earth in orbit around the Sun. So we're going to stop this, and we're going to follow the directions. Click on gravity force. So we want to see which way, we're going to go back to the Sun and the Earth. So we're going to say, what do you think these gravity force arrows represent? This is part 2A. So what do these arrows represent? B, what do you notice about the size of the gravity force arrows between the Earth and the Sun, which is what you see now, and the Earth and the Moon? What do you notice about the size of those arrows? So here's the first size, and here's the second size. So if you notice anything, that's part 2B. In what direction do the arrows point? So regardless which one I'm looking at, in what direction do the arrows point? What do you think this means? That's part 2C. Part 2D, based on your observations, how would you define the word gravity? I have a feeling you may have already done all of those things, but let's go to part 3. Okay, so what I did was I followed the directions for part 3, and I clicked on all the things I'm supposed to have on my picture. So I've got the Sun and the Earth, and why they're not showing up very much, I don't know. But what we're seeing is that the Sun, which is labeled star here, is 333,000 times as massive as the Earth. So we say there's one Earth mass, and 333,000 Earth masses make the star. So what we want to do, I'm trying to read at the same time, we want to change the revolution. So let's go ahead and start it and see what we have here. So here we go. We're going to change the revolution. And it's like, what would change the revolution? So this is what it is right now. And we're going, okay, we just saw that. We just don't have the moon and the sun as little round balls right here. They're really tiny. So what would change the orbit? So we're going to try this. We're going to make the sun even bigger. So now the sun is 490,000 Earth masses. The Earth is still one. So we have one mass of the Earth. The sun is now 490,000 times more mass. We're going to start that, and we're asking ourselves what happens to the orbit. So a couple of questions. How many days does it take to make one revolution? I'm going to clear this. Let's start from here at 0 so that you can see how many days it takes the Earth now to make one revolution. And it was about there. It was about there. So 200 Earth days to make a revolution. What happened to the gravitational force arrows? It's a little hard to see because they overlap so much, but I think you get the idea if you... This was what it was at first. This is what it is now. What are two observations? Observation about... a little bit past where it was. Observation about the orbit, observation about the speed of the orbit. What are two observations that you make? So that was by increasing the mass of the sun. We're going to clear everything, reset this. So now we're back at our original size of the sun, original size of the Earth. Here's our gravitational arrows. Here's our comparison of masses. What would happen if we made the Earth 1.5 mass of its current size? So we're going to say that this stays the same, the sun stays the same, Earth is now 1.5 times more mass than it really is. So look at what happened to our arrows. And we're going to start on 0 Earth days because we're going to be looking at a couple things. I'll only let it make one complete revolution. I went a little bit past. It's almost the exact same number of years, a number of days to make one complete revolution. So that didn't seem to affect it a whole lot, did it? It still had an orbit, somewhat elliptical. Maybe it was a little bit closer, but I don't know. I'd have a hard time telling that. So what we could do is make the sun smaller, and let's see what happens. Let me bring the Earth back to its regular size, because we only want one variable. And now we've made the sun smaller. Let's see what happens. Uh-oh. Notice how much smaller that arrow is, and it's getting smaller and smaller and smaller. What does that tell us? Unless something really, really, really weird is happening. What's happened to the Earth? We can't see everything, but we can make a pretty good idea, because notice this gravity is really, really small. Now if it comes back and gets larger, then that means the Earth is coming back around closer again. But somehow I don't see that happening even after almost 1,000 days. So we made the sun much smaller, kept the Earth at the same size. What happened? What happened to the gravitational force arrows? How many days did it take to complete one revolution? What are two observations you made? So these are the kind of changes we are making. We have one more change to make. Let's see. We could do anything we wanted to. If we put gravity off, then I think we know what's going to happen. So what if we make the sun larger and the Earth smaller? So let's make Earth half its current mass, and we're going to increase the sun by about 50%. Let's see what happens. Gravitational forces increase, decrease. Interesting. I haven't tried all these scenarios. Look how close the orbit is at one point. It's twice as close at one point than it is in another. So it's super elliptical. The sun is definitely not in the middle anymore. Interesting. You can probably stop this video and go back and see how long it takes to make one complete revolution for a year. So that's really all you would use the simulation for. After that, it becomes questions about what you know about gravitational pull. I know it wasn't that interesting, and I know that you probably got that whole first part already, but at least it gives us a start and helps you to finish this. So I hope that helps.